Well, Professor Weil, a mathematician, gave an excellent definition of symmetry. It's this. As I am left and right symmetric, that means that if you put everything that's on this side and vice versa, if you just exchange the two sides, it'll look exactly the same. Or, for instance, a square has a symmetry because if I turn a special kind, if I turn it around to 90 degrees, it still looks exactly the same. So, Weil said, a thing is symmetrical if there's something that you can do to it so that after you finish doing it, it looks the same as it did before. And then that is the sense in which we say that the laws of physics are symmetrical. That there are things that we can do to the physical laws or to our way of representing the physical laws which make no difference and leave everything unchanged in its effects. And this aspect of physical laws are what's going to concern us tonight, and we will take a number of examples. The simplest example of all of a kind of symmetry, as you'll see, it's not the same as you would have thought, left and right symmetric or anything like that. There's a symmetry called translation in space. That has the following meaning. If you build any kind of apparatus or do any kind of experiment with some things, and then go and build the same apparatus or do the same kind of experiment with similar things, but put them here instead of there, merely translate it from one place to the other in space, then the same thing will happen in the translated thing that would have happened in the original thing. It's not really true, actually. If I actually built such an apparatus and then displaced it 20 feet in that direction, it would get into the wall and there would be difficulties. It's necessary in defining this idea to take into account everything that might affect the situation, so that when you move the thing, you move everything. For example, if the system involved a pendulum, and I moved it 20,000 miles to the right, it wouldn't work right anymore because the pendulum involves the attraction of the Earth. But if I imagine I move the Earth and the equipment, then it will behave the same way. So the situation is that you must translate everything which may have any influence on the situation. Now that sounds a little dopey because it sounds like, well, just translate it, and if it doesn't work, then you didn't translate enough stuff, and you're bound to win. Actually not. You see, it's not self-evident that you're bound to win. The remarkable thing about nature is that it is possible to translate enough stuff so that it does behave the same way. That's a positive statement.